Hi guys, welcome to my channel, welcome to the Alphas Academy. Last time when I was looking at A-level pure mathematics, I was doing part 1 of the first topic of pure mathematics. We're looking at polynomials and functions, right? So today we're going to go over part 2 of polynomials and functions. We're going to finish polynomials and functions today. So if you haven't liked my videos yet, if you haven't subscribed to my channel yet, please do so today, and feel free to share with friends and family so that they can know where to get good and affordable stuff, high quality notes for A level, high quality notes for O level as well. I do not look at pure mathematics only, I look at many other subjects, but for today we're going to look at pure mathematics part 2 of polynomials and functions. Let's get down to business, shall we? Okay, so on this page we are looking at completing the square, right? We are continuing polynomials and functions. Now we have an example. We take ax squared plus bx plus c to be our quadratic expression. Hence, if we are asked to complete the square of that expression, what do? We go over the following steps. The first step being, make sure that the coefficient of x squared is equal to 1 at all times, right? And the only way to do that is to divide the whole expression by whatever coefficient is on x squared. For example, in this case, we divide each and every term in that expression by a, or positive a, and finally we get a open bracket x squared plus b over a x plus c over a. Please note that we have factored out a from the equation. So now we have that, and we are saying that the next step is to add the square root of x squared to the half of b over a, which is the coefficient of x. Now you bracket and square that answer that you get. So what are you doing here? We're saying root of x is equal to plus or minus x normally, but in this case root of x is equal to plus x only for the situation that we have here. So we are saying that the square root of x squared is root of x squared. Please correct that. Root of x squared is equal to plus x only in this case. So you take the root of x squared, which is what you had in the first place, ax squared plus whatever. So root of x squared, there you have x, and we are only taking plus x in this case, plus b over 2a. So that's what you do. You say plus b over 2a. So finally, b over 2a, you get it from saying half of b over a. It's like b over a divided by 2, right? Which is b over a times 1 over 2, which is b over 2a. So x plus b over 2a squared is the first part of your answer. Now you add that to c and subtract the square root of half the coefficient of x, right? So we're saying that x plus b over 2a close bracket plus c. So there should be a c there at the bottom of the page. There should be a c. It's plus c minus what? B over what? Over 2a squared. So that's where you end up getting, and you're saying that from there you go on to say, if you say that's your answer there. If you say x plus b over 2a squared plus c minus open bracket minus b over 2a close bracket squared, I want you to put a c there at the bottom of the page. There should be a c. Then you say minus open bracket minus b over 2a close bracket squared is equal to 0. My apologies for that mistake. Please feel free to correct that. Thank you very much in advance. So if you deal with the last part only, c minus open bracket minus b over 2a close bracket squared, right? If you square what is in the bracket there, you get b squared over 4a squared. So you're now saying c minus b squared over 4a squared. You make 4a squared your common denominator, you end up getting 4a squared c minus b squared O over 4a squared, which is the last part of completing the square. Now you unite that last part with the first part, which is x plus b over 2 close bracket squared, which is shown on the upper right hand corner. It's x plus b over 2 close bracket squared plus 4a squared c minus b squared o over 4a squared. Now we had factored out a, so to finally complete the square we need to factor in this a, right? So you have to multiply it by the answer that you get. You have to multiply it by the completed square, the half completed square that you have there to get a. Open bracket, open another bracket, x plus b over 2a close bracket squared plus 4a squared c minus b squared o over 4a squared close that bracket. That should be your answer there. You can go on to making this simple, but yes, you can end up having a open bracket x plus b over 2a close bracket squared plus 4a squared c minus b squared over 4a multiplied by it's just like that. The 4a squared was multiplied by an a to get 4a, as we are seeing there in the encircled section of that answer. So where this part determines the maximum or minimum value, we're going to talk about the maximum and the minimum value, but I believe we have looked at that in our part 1. If you haven't watched my part 1 video, polynomials part 1, the link is in the description below. Feel free to go and access it, and also put a like if you can. So if that there, an example now, you're asked to complete the square of x squared minus 6x plus 8, right? Simple steps. You say square root of x squared, you get x. In this case, you don't need to factor out anything because the coefficient of x squared is already plus 1, so there's no need to do that. So you're saying square root of x squared, you get x, subtract, right? We are subtracting because the coefficient of x is what? Is negative. Negative what? Negative 6. We are subtracting with what? The half of that coefficient of x, right? Which is now finally x minus 6 over 2. Close bracket squared plus c. Our c in this case is 8 minus open bracket the half of the coefficient of x squared. The coefficient of x, that's the one that we want to say half of that, and then we square what we get finally from there. So x minus 6 over 2 close bracket squared plus 8 minus open bracket minus 6 over 2 close bracket squared, you get x minus 3 squared plus 8 minus 9. Alright, so I was saying we have an example there. We're asked to complete the square of x squared minus 6x plus 8. Now the coefficient of x squared is plus 1, the coefficient of x is minus 6, the coefficient of 8 it's just a term, it's a known term, so there's no need to say the coefficient of that. It's just a c. Our b is minus 6, our a is plus 1, so everything is fine there. We simply go on to say that, or if you want to make things simpler for you, enter your examination knowing the above expression. A open bracket x plus b over 2a close bracket squared plus 4a squared c minus b squared over 4a, right? You have to enter your examination knowing that. Even if you do not want to enter the examination knowing that, the last part at least know it, because you might be asked to just calculate the maximum or the minimum value. You simply need to say 4a squared c minus b squared over 4a. That's the minimum or the maximum value. So if you do that, you're now substituting for a, b and c. A is plus 1, b is minus 6, c is plus 8. So you're just substituting the and finally you're going to get x minus 3 squared minus 1. So if you have that, you are saying that the coefficient of x squared was positive, therefore the expression is a minimum turning point, right? Because the coefficient of x squared was positive. We talked about this again in our part 1. I kindly refer you back to my part 1 polynomials and functions video. But minimum value is equal to 4a squared c minus b squared over 4a. You can calculate that to find your minimum value, which comes back to where you have completed your square. If you look at the last part, which is minus 1, it is also the minimum value. So you can use this method or just go back to your completed square version. You take the last number, that will be your minimum or maximum value. I look at the next page. On this page, we are saying that the relationship is hence shown in that way. We are saying our A is 1, x minus 3 close bracket squared plus open bracket minus 1 close bracket. We are currently matching, we are sort of doing that in some sense. So in other words, the minimum value here is the y coordinate on the Cartesian plane. To find the x coordinate, what do? You equate whatever is inside the bracket to 0. You equate x plus b over 2a to 0. In this case, x minus 3 is equated to 0, and you get x is equal to 3. Therefore, the stationary point, right, or the minimum or maximum point, will have 3 as its x coordinate and minus 1 as its y coordinate. Conclusively, x minus 3 squared minus 1 is equal to 0. The y-intercept as coordinates is 0, a, where the coordinates of x is equal to 0, like that. So that's another equation that I'm looking at for the second part on our conclusion there. So to find y, you substitute for values of x in the equation x minus 3 squared minus 1, which is equal to y. So you're saying y is equal to negative 3 squared minus 1, you get 8. So to get that y-intercept, to get the y-intercept for our given situation, you are simply equating to 0. The moment you equate to 0, you will know that automatically the y-intercept, the value of the x-coordinate is equal to 0. So you are simply substituting 0 into the expression of your completed square to get the y-coordinate or the y-intercept there. We now have 2 points, the minimum turning point and the y-intercept. If you have got those 2 points, you only need 2 points to draw a line. You only need 2 points to draw a curve as well. If you know what a curve looks like, you only need only 2 points. So if you have got that, you are simply now saying that we've got the y-intercept, so we know how it cuts the y-axis, and then we've got the minimum turning point, so it looks like a cup like that. You can show it like that. If you want to get the roots of that that expression, you simply need to factorize it and go over the same procedure that you have went through when you're doing your O level. You can use the quadratic formula, whichever method suits best to you. But what if the coefficient of x squared is not 1? Remember, we factor out the non-1 constant initially as shown below. Complete the square of 3x squared minus 6x plus 9. You factor out 3, you've got 3 open bracket x squared minus 2x plus 3. From there, you say you leave the 3 aside, and then you deal with whatever is in the bracket. So x minus 2 over 2 close bracket squared plus 3 minus open bracket minus 3 over 2 close bracket squared. You go on to have x minus 1 squared plus 2. Now you factor the 3 back in to get 3 open bracket x minus 1 close bracket squared plus 6. So that's what you get on the next page there. On this page now, I've illustrated what you are going to get if you factor in 3. So the minimum value, since the coefficient of x squared is positive, it has got a minimum value. So the minimum value there is positive 6. Right? If you want to find the y-intercept, you just put 0 in place of x. Right? You have that, whatever answer you get there, that's your y-intercept. By time, it will no longer be essential to square any a in the expression 4a squared c minus b squared over 4a. As such, this book encourages learners to use this formula 4ac minus b squared over 4a for the purpose of maximum accuracy. Using 4ac minus b squared over 4a will give you where you've got a, that's 3, b is equals to minus 6, c is equals to 9. You can hence come up with your value, maximum value or minimum value there. So the minimum value, the minimum turning point there is 1, 6. The y-intercept is 9. You can use the method that we've taught each other. Now from here you can be asked, there's a diagram there. Please accustom yourself to drawing these diagrams. They are very essential to A level, pure mathematics, IGCE, A's and A level, or A level zimsec. Now complete the square of negative 4x open bracket x plus 1. The first thing that you need to do is to expand that to get negative 4x squared minus 4x. The coefficient of x squared should be positive 1 in order to complete the square. So you factor out negative 4 to remain with x squared plus x. Therefore, in that situation, our a is now 1, our b is now 1 as well, our c is equal to 0. So you are substituting, you get x plus the coefficient of x, which is 1, divided by 2, you've got 1 over 2 there, close bracket, squared, plus c, which is 0, minus half the equation of x, which is 1 over 2, square that. So finally we've got x plus half squared minus 1 over 4. But you can't say that is the final answer, because there is that negative 4 that you have neglected. You need to put it back in. So multiply whatever that you get by negative 4, and finally you have negative 4, open bracket, x plus half, close bracket, squared, plus 1. Note that on negative 4x minus 4x, negative 4x squared minus 4x, the equation of x squared was a negative. The expression now, because of that, has got a maximum turning point. By virtue, the maximum value is equal to 1, and the maximum turning point is equal to negative half 1. Moving on the next page, the y-intercept can be calculated by simply substituting. For x you put 0, so negative 4, open bracket, 0 plus half, close bracket, squared, plus 1, you get negative 1, plus 1, you get 0 as your y-intercept there. Quadratic inequalities. You have got x squared is less than 12 minus x. Now you might be tempted. You might be tempted to just solve it as it is, but then there are some steps that we expect you to follow. The first step is to rearrange, to leave one side equal to 0. So you rearrange to have finally x squared plus x minus 12 is less than 0. From there you factorize the resultant quadratic. You have x plus 4 multiplied by x minus 3 is less than 0. From what you have done so far, you can now produce what we call critical values by equating these factors to 0, these two individual factors to 0. X equated to 0, you get x is equal to negative 4 and x is equal to 3 there respectively. The critical values emanate from those values of x that which you would have equated to 0, which are negative 4 and 3. Those are your critical values. Now, how do you use the critical values? You create a table as shown on the next half of this page. So using the table below, you start with the minimum critical value, which is negative 4. So you say for values of x that are less than the lowest minimum value, negative 4, what do you get if you substitute any value that is less than negative 4 into either x plus 4 or x minus 3 and the whole function? Do you get a positive answer or a negative answer? That's the question we are asking ourselves. So we take an example of maybe negative 7, right? If you substitute negative 7 into x plus 4, you get negative 7 plus 4, which gives you negative 3. Negative 3 is a negative answer, so we put a minus, right? Where our column for x is less than negative 4 and our row for x plus 4 coincide. That's where we put our minus. For x minus 3 is negative 7, negative 3, you get negative 10. It is a negative answer. So the point where these two, where this row and column coincide, you put a negative as well. You go down to say, what about the whole function? The whole function contains both these factors multiplying against each other. So it is more like we are saying these negatives multiplied against each other. If you multiply a negative to a negative, you get a positive. That's why I've put in a positive there. For the next column, where x is greater than the least critical value but less than the highest critical value, we are looking for a number that is in between there. For example, 2. So if you put 2, or if you substitute 2 into the expression x plus 4, I'm sure you get 2 plus 4, which is positive 6. That's why we've put a plus there. You go on to the second row, we've got x minus 3, you put 2, you say 2 minus 3, you get a negative answer there. On the last part where x is greater than 3, we are saying that, let's take an example of 10. 10 plus 4, we get 14, positive 14. So we put a plus on the square where the column x minus x is greater than 3 and the row x plus 4 coincide, you put your positive. The same for x minus 3, you take where x is equal to 10, 10 minus 3, you get positive 7, you put a positive again. If you multiply the 2, you get a positive. You multiply the positive and minus under the column x is greater than minus 4 but less than 3, you get a minus as well. So finally you can say, let x plus 4 multiplied by x minus 3 be equal to x squared plus x minus 12. be the polynomial f of x. So your answer there, you are being asked, what are the values of x for this polynomial to be less than 0, right? Any number that is less than 0, it is negative. So where do you get your answer from that table? You look at f of x, the row for f of x, where do you have a negative? We have a negative in the third column, where we've got x is greater than negative 4 but less than 3. That negative denotes that whatever value of x that we put in our polynomial, we are deemed to get a negative answer, a value that is less than 0. Therefore, that is our answer. The proof there, we say maybe negative 3 squared, it's a value between negative 4 and 3. So negative 3 squared minus 3 minus 12, you are bound to get an answer that is less than 0. You put 2 squared plus 2 minus 12, you are bound to get a value that is less than 0. So finally your answer is negative 4 less than x, where x is less than, remove that 0 there, it was a mistake, it's x is less than 3. So your answer is x is greater than negative 4 but less than 3. Narration of the table, I have talked about it, but out of interest, you can just look at this. You can just try and interpret the table as I've explained. I believe you get the idea there. I've explained it before. Now we can look at another step. We can look at another step or another method, step 4.1. Now we can use a graph to find these values. How do you use the graph? First, of course, you factorize, and then if you factorize, you get the roots, and then you also recall that the coefficient of x squared is a positive. Therefore, the graph is cup-shaped. You draw a graph like that, and then you shed a part that is less than 0. The part that is less than 0 is the part below the x-axis, right? So the part below the x-axis is the part that is less than 0. The part above the x-axis is the part that is above that is above 0. So there you can just go on from there. The x-axis marks the line y is equals to 0 according to O level, which is ordinary level or IGCSE. For parts below the x-axis, it is true to assume that they are below 0. But in what range is the graph less than 0 as demanded by the question? It is clear that it is true when x is greater than minus 4. If you look at that, you come back to numbers, right? If you're not good at your numbers, integers and stuff, number lines, directed numbers, please go to my mathematics O-level video, how to pass O-level mathematics. I will also put the link down below for you to go back. So it talks about these directed numbers, and then how do you show them from a certain range, like x is greater than minus 4 but less than 3. You can just go back to that video and have more knowledge on these directed numbers. An example there, we've got x plus 3 squared is less than x open bracket 4 minus x close bracket plus 40. Let's try and play around with that. So we are going to expand both sides. Of what x squared plus 6x plus 9 is less than 4x minus x squared plus 40. If you rearrange, you get 2x squared, right, plus 2x minus 31 is less than 0. Is 2x squared. Put that squared, please. So the coefficient of x squared is positive 2. The coefficient of x is 2 as well, positive 2. The coefficient of or the c is negative 31. You can use the quadratic formula and you get x is equal to negative 2 minus 6 root of 7 all over 4, or minus 2 plus 6 root of 7 all over 4. You can draw the graph like that and then shade the part that is below the x-axis, since our answer requires those values that make this polynomial less than 0 if they are applied on the polynomial. So the values of x are ranging from negative 2 minus 6 root 7 over 4 to negative 2 plus 6 root of 7 all over 4. I'll move on to the next page. On this page, we are saying, okay, our answer there, we have it. So we have it as x is greater than negative 2 minus 6 root 7 all over 4, but it's less than negative 2 plus 6 root of 7 all over 4. Rational fractions in inequalities. Put into consideration the inequality below. X plus 6 over x minus 4 is less than 3. It would be wrong for us to assume that x minus 4 is a number that is greater than 0 for all the values of x. What if you put negative 100? Negative 100 plus 6 you get negative 94, which is not greater than 0. So it is wrong for us to assume that that expression or any of the two expressions are greater than 0, which now arrests us or denies us the ability to cross multiply. We cannot cross multiply because of that fact, right? We're not sure if our value of the expression, the real value of that expression, is greater than 0, so we can't cross multiply. We need to rearrange and put on the same side. X plus 6 all over x minus 4 minus 3. That's what you do. From there you solve your fractions. If you don't know how to solve fractions as well, the link is in the description below on how to deal with fractions back at O-level IGC, SE, O-level mathematics, how to pass O-level mathematics. So we've got that now, and when you rearrange, there are cases of course that you can cross multiply. For example, x minus 2 all over x plus 5 squared, you can cross multiply. That will be of no problem. Why? Because the denominator has been squared. And we remind each other that any number that is squared becomes positive, so there's no need to worry about that, it being positive or negative. Now, there are two ways of solving this inequality that I've talked about. You rearrange and then you solve is you just solve normal fractions. You are saying that for example, a third plus 2 is the same as saying a third plus 2 over 1, common denominator 3, therefore 1 plus 3 times 2 you get 6, 1 plus 6, 7, 7 all over 3. The denominator is not changing, right? It is not changing as it is like that. So I've got a situation like that, and then you try to solve it the same way we solve fractions, and we get negative 2x plus 10 all over x plus 4. From there now, that is less than 0. Of course, you need to come up with the critical values. How do you come up with the critical values? You take the numerator, you equate it to 0. You take the denominator, you equate it to 0. Those are your critical values. You've got x is equal to 5 and x is equal to 4 as our critical values. Using our critical values on the table there, you can say the values of x that are less than 0, what are that less than 4, what are you getting for negative 2x plus 10? You get, for example, 1. Negative 2 plus 1, that's positive 8, so we put a plus. What about if you say 1 minus 4, you get a negative 3, so you put a minus there. You say plus divided by minus. Remember, if different signs are divided into each other, you get a negative sign. For the second column, x is greater than 4 but less than 5. You look at 4, 5. Negative 2 times 4, 5, you get negative 9. Negative 9 plus 10. What you get? You get a positive answer there, positive 1. Negative 4, 5 minus 4, you get a positive answer as well. And the values of x that are greater than 5, you've got 10. 10 multiplied by negative 2, you get negative 20. Negative 20 plus 10, you get negative. So you put a minus there. If you take 10 minus 4, you get a positive. So minus divided by a positive, you get a negative. Plus divided by a plus, you get a plus. We need those values of x that give our polynomial being a negative, or that gives our polynomial being less than 0. So here we've got two answers. X is less than 4 and x is greater than 5. The second method, if by any means you want to cross multiply a linear denominator, you make the multiple a square of the linear denominator, right? What am I saying? 3 over x is less than 2. How do you do that? You say x squared, right? You take x squared, that's a multiple of our denominator. We multiply it by 3 over x. You do the same on the right hand side. That's how you can cross multiply. You can say from there you are getting 3x is less than 2x squared. Rearrange from there, you got 2x squared minus 3x. A is equal to 2, b is equal to minus 3, c is equal to 0. You can solve it as it is there to go on to have x is equal to 0 or 3 over 2 as your critical values or as your roots. You can draw that as simple as that, where the coefficient of x squared is being positive in this case, and then it's greater than 0, so it's above the x-axis. On the left you say the graph is above the x-axis when x is less than 0. On the right, you say the graph is above the x-axis when x is greater than 3/2. Like that, you look at simultaneous equations. We've got x is equal to y minus 2 as our first equation, x squared is equal to y as our second equation. This is simple. We simply can substitute for values of x from equation 1 to equation 2. That's what we do, right? So you are simply now saying y minus 2 squared is equal to y squared minus 4y plus 4 is equal to y. We've expanded that, and finally we've got y squared minus 4y minus y plus 4 is equal to 0, y squared minus 5y plus 4 is equal to 0. You try to factorize that, and you end up getting y minus 1 multiplied by y minus 4 is equal to 0. Therefore, y is equal to 1 or 4. We now want to find the values of x given y is equal to 1 or 4. So you are simply substituting now those determined values of y into any of the two equations to find the values of x, as shown on this page, which is the next page. So finding the values of x, you are simply saying x is equal to 1 minus 2, x is equal to minus 1 there. So you found the value of x given a certain value of y, which is what? Which is 1. So if you have that now, you can say this is a point. It makes a point of both x and the y. So negative 1, 1. The second one is negative 6, negative 4. You're asked to solve again. Y is equal to x squared minus 3x plus 2. And y is equal to 3x minus 7. Apparently, y from equation 1 is identical to y from equation 2. In what sense? It's just that these are y's that you're dealing with. If y is equal to this and y is equal to that, then whatever these y's are equal to, they are also equal to each other. So after equating and making sure that the left hand side and the right hand side equal or are equated, we can find the discriminant in order to find the type of roots present in these two y's combined together. So if we've got x squared minus 6x plus 9, you can use the way of calculating discriminant b squared minus 4ac. Your answer, I believe, you get something that is 0. So it has got one real and repeated root, right? It is neither below nor above the x-axis. It is just on the x-axis because it has got a real and a repeated root. Hence, the resulting equation has one real and repeated root. The line 3x minus 7 is intersected or touched, or it touched or intersects the curve x squared minus 3x plus 2 at one distinct point, making it safe to conclude that the line is a tangent to the curve. That's how we find the nature of a line to a certain curve. We simply take the equation of the line, the equation of the curve, we group them together, we get it to 0, we calculate the discriminant. If you get the discriminant being equal to 0, it means that line is a tangent. Why? Because it only touches the curve once. As we said, it has got one real and repeated root. Carrying on, x squared minus 6x plus 9, we're trying to factorize that, and we end up getting x minus 3 multiplied by x minus 3 is equal to 0, and you get x is equal to 3 twice. We have proven our point. This line touches the curve at one real and repeated root. Substituting for the values of the determined values of x is equal to 3 in any of the equations 1 or 2, we get y is equal to 2. Therefore, the point of intersection is 3, 2. The line touches the curve at that point, being its tangent. We move on to the next page. On this page, we are looking at quadratic equations in some functions. Equations can be given in the form x to the power of 4 minus 6x squared plus 9 is equal to 0. Remember that x to the power of 4 is the same as saying x squared to the power of 2. So we firstly write the equation in a different way to solve it. We now go on to say x squared to the power of 2 minus 6 open bracket x squared, you close the bracket after the squared, plus 9 is equal to 0. Now, to properly solve this, you have to substitute the x squared, right? You say let x squared be any other letter, e.g. y, let x squared be y. So finally, we are now saying in place of x squared, we are putting y. Therefore, the equation can be rewritten as y squared minus 6y plus 9 is equal to 0. You are trying to factorize that y squared minus 3y minus 3y is equal to 9 is equal to 0. Y multiplied by y minus 3 multiplied by y minus 3 is equal to 0. So finally, we've got y minus 3 squared is equal to 0. Y is equal to 3 twice. But we said let x squared be y. Therefore, x squared is equal to y. x squared is also equal to the answer that we got 3. X is equal to root of the answer that we got 3. X is equal to plus or minus root of 3. Second example, y is equal to 2 root of 3 minus 3 being equal to 0. You're asked to solve that. You ask yourself, what value or what number can I square to get a certain number that I want for this certain it's obvious that minus 2 is a coefficient of x. So we are saying that what number do I find the square root of to get a single or a linear expression, right? So it's very easy to now assume that your y can be x squared, so that when you say negative 2 root of x squared, you get negative 2x, like that. So there you are saying x squared minus 2 root of x squared minus 3 is equal to 0. X squared minus 2x minus 3 is equal to 0. You solve that to get x plus 1 multiplied by x minus 3 is equal to 0. X is equal to minus 1 or 3. But y is equal to x squared, right? So you say y is equal to negative 1 squared or 3 squared. That's what we do. Y is equal to 1 or 9. Another example, x to the power of 2 over 3 minus 3x to the power of 1 over 3 minus 4 is equal to 0. Remember that if you say a to the power of 3 over 2 is to the power of 2 over 2 is the same as saying a to the power of 1 over 2 multiplied by to the power again of 2 or squared. That's what you can say. So x to the power of 2 over 3 is the same as saying x to the power of a third to the power of again, or you can say squared. So hence now you can say x to the power of a third squared minus 3x to the power of a third minus 4 is equal to 0. You substitute that value that is difficult to calculate, x to the power of a third, let it be y. So you are saying y squared minus 3y minus 4 is equal to 0. Y squared is equal to minus 4 plus y minus 4 is equal to 0. Y open bracket y minus 4 close bracket plus 1 open bracket y minus 4 close bracket is equal to 0. Y plus 1 multiplied by y minus 4 is equal to 0. Therefore finally y is equal to negative 1 or 4. But x to the power of a third is equal to y, right? We said x to the power of a third, let it be y. So x to the power of a third is equal to y. The value that we got for y, the values are negative 1 and 4. So you're saying x to the power of a third is equal to negative 1 or 4. Right? To remove the third or the cube root from x, you need to triple or treble whatever is on the right hand side. Right? So x is equal to negative 1 cubed or 4 cubed. Finally, you get x is equal to negative 1 or 64. There are revision questions there. There are revision questions, and on these revision questions, I want you to look at them. First of all, I want you to look at them. When you look at them, you attempt them. You pause this video. Look at the first left-hand side. You look at the second right-hand side, like that. When you look at these questions now, there are answers that are following. In this same video, there are answers that are following. So I believe I can cut or I can end my lesson here so that you look at these revision questions. If you have any questions regarding polynomials and functions, ask me. If you are not understanding how some of these questions went about, ask me as well. I'll be more than happy to assist. But as for now, I want to leave you and do your own thing. Try and attempt these questions. Pause this video at this exact point and look at these questions, all of them. Try them, attempt them using the notes or using what I've told you earlier on from part 1 to this part 2. There are answers that follow from these questions. The answers that follow, I've answered each and every question that I've set unto you. Just look at these questions. You never have polynomials and functions troubling you ever again. So for these answers there, you look at them. These answers, you look at them. wisely. Maybe for the previous page, let me go back. On this page, I believe we didn't look at the left hand part of this page. So this is the left hand part of this page. Look at it and make sure that you can take a screenshot or pause this video at this exact point. That inside is like that. You take a picture at this exact point. You look at the next page, you take a picture at this exact point like this. If you are done, you can take a picture of the right hand side like that. If you are done also on this page, you look at the next page, you take a picture for the right hand side like that. If you are done with that, I will allow you to take a picture on the other side like that, so that you have every detail that I want you to have. We look at the next page, which is the last one. You take a picture. We are solving the last question. Thank you very much for attending today's lesson. Please share this video with friends and family. Please subscribe to my channel. I am begging you. Thank you in advance for subscribing to my channel. You won't regret this. Even in 1,000 years, you won't regret this. Thank you very much once again for attending today's lesson. Have a very good day.